functioning of these particular thing work. But there is a requirement to know about the history of fuel cell, right? Like it is not a new technology. Basically, it's invented in 1839. These these historical perspective is basically sometimes very important because we have no idea like when a certain technology came into existence, right? So to aware of it, how long it has been till this technologies exist. So it is important to know from where we have started. Right, we have started from 1839 as a year. This year, this technology was invented by the William Grove. So that is the first developer of this technology. If you are interested to know, so it is also very interested to know that which year the inventions happens and who is the person who actually who invented this particular thing. Right, Grove was experimenting on electrolysis, the process by which water is split into hydrogen and oxygen by an electric current, right? When he observed that the combining the same element could also produce an electric current, he was basically what he was doing, like he was trying to process by which the water is split into hydrogen and oxygen by the electric current, because that is what we do when we want to produce the hydrogen, right? So that is the reason this is the we have to give energy to that particular process so that we can develop the hydrogen. And when we do this, when we he observed, when he was doing this entire experiment, he observed that the combining the same element could also, if you are combining this element, means this process is reversible, right? So it can be moved into both of the directions. Like it is like if you can break them into the hydrogen and oxygen, right? If H2O, which is like water, if H2O is convertible in which form is convertible in H2 and H2 and O2, right? H2 and O2. So the same process will be also converted into vice versa. Means to converting hydrogen means to converting water into hydrogen cell and oxygen. We need to give energy to this particular system. So we are giving energy. So once we have given energy, and this water molecule will break into hydrogen and oxygen. The same time, the same thing when we have like it will break into hydrogen and oxygen. But if you will look into the reversible portion of it, when you are means when you have like when these two particles are combined together, when we have combined both of these particles, then the combination of these particles, then the clubbing them together, these particles will basically give us the will also give us which also produce will give the means it will produce the electricity if we'll go in the reversible mode, right? So this is the basically the starting of this particular technology. Then then from the 1930 to 1950, certain different experiments happen in the same cases. Well, we have alkaline fuel cell were developed. Then the starting of this working started in 1958. The technology was licensed to the patent, right? Then the advantages over conventional energy storage. So this is the one of the again the important area. What is the basic advantages we have over the conventional sources? Like because both of the technologies available, both of the things is available, we can still have the electricity from some other sources, and we can also have the opportunity to save energy into the different forms. But so what is the how this is better than the other one? So advantages over the conventional energy sources, when we have if we consider this particular thing, they produced almost zero or very low emissions, because technically there is no emission other than the process when we are breaking the hydrogens, right? When we are breaking the hydrogen, when the H2O is breaked into hydrogen and oxygen, in that particular case, what happening actually, to break the water molecules into the hydrogen and oxygen, it is basically taking energy. We have to give energy, we have to put energy, or that particular energy. It is like most of the time, even if they are that what I was talking yesterday, like the American entire hydrogen industry. It is like based upon the coal power plants, because the coal power plants are basically supplying the energy. Through this particular supply of the energy, the water means the hydrogen is subtracted from its basic compound, right? Because again, the process of electrolysis need energy, and once you will put energy, then only it will break into the hydrogen and oxygen, right? To breaking of this particular water molecule into the two different components, right? So to do that, we need to put energy. So they produce zero or very low emissions. But if you look into the next part where we have like this fuel cell technology, and we are putting one side anode side and the cathode side oxygen and hydrogen, then this is this different thing. Means this is like in this particular transactions where the both the flow is taking place in the alkaline medium, then this is the different thing. Means in that particular case we have already the hydrogen, we have actually the hydrogen fuel, so that is just the converting the fuel into the electricity. But if you look back and look into the entire process of this conversion, but what you have done actually at the very basics, we have actually putted energy to converted this particular water molecule into the hydrogen, right? There in that particular side we are actually using the conventional source, and which is basically the reason it is emitting with the emission issues with that particular side. But not if you look into the second side, have few moving parts and does require minimum maintenance. It is basically nothing. Yeah, it's just the hydrogen cells, oxygen in one side, they are combining together, water is coming out as an end product, and the energy is releasing, because it is a reversible process. It is taking place. If you will give energy to the water, it will break into the two particles. If you have the if merge these two particles, energy will be released, right? The I exothermic and endothermic reactions is basically the part of this particular chemical convergence process, right? So one side it is like the exothermic, and the another side is the endothermic. So this is the way this entire thing is taking place. Modular in design, offering flexible in size and efficiencies in manufacturing. So it can be have any size, even size, and the basic requirement is the hydrogen along with oxygen. So the combinations of the hydrogen and oxygen is basically providing us the energy required for the production of electricity. So this is the fundamental. If we ask like in which year, I'm asking both of you, in which year this particular fuel cell technology invented? When we have discovered this particular fuel cell technology? Nishant and Hitesh, when we have discovered this particular technology? Nishant, when the fuel cell technology discovered? When did we discover this particular technology? Okay, like this is the thing, and it is basically the module in design of flexibility it is offering, and can utilized for combined heat and power purposes. It can We can also utilize it for the energy generations. Energy can be anytime, it can be electrical energy, it can be a heat energy, so increasing the efficiency of energy, and it is also increasing the efficiency of the energy productions, right? Working principle: a fuel cell is a device that uses hydrogen. It is basically a device. Fuel cell is basically a device in which we have used the hydrogen fuel cell as a fuel, right? So the fuel cell is a device that uses hydrogen or hydrogen rich fuel. So we are using in this particular case of fuel cell, we are using hydrogen and the hydrogen rich fuels and oxygen to create electricity by an electrochemical process. So it is technically that particular process, because the electrodes are used into this particular thing, so we call it, or the reaction which is taking place is there is chemical. If we combinations of both of this, what is basically happening in this particular case, the combinations of both of these process, which is like the electrode in one side and chemical reaction is the other side, is the combinations, we call it electrochemical process, right? So the electrochemical process will actually able to produce through this particular device, we are able to produce energy from this particular thing, right? A single fuel cell consisting of an electrolyte sandwiched, right? A single fuel cell consisting of an electrolyte sandwich between two thin electrodes. The same thing, one side is anode, the another side is cathode. It is basically sandwiched through the electrolytes, right? So electrolytes are in between. From one side we have the oxygen, one side we have the hydrogen, and the flow of them, due to the flow of the electrons, we are able to directly generate the electricity without having any fuel consumption, which is not possible in the traditional ways. Like in the traditional ways, whatever we technologies we have, whatever we have, we are not able to produce this. Hydrogen or hydrogen rich fuel is fed to the anode. Anode side is for the hydrogen, and the cathode side is, right, where the cathode side, when the cathode side separates hydrogen's negative charge electrons from positively charged ions, or, right, at the cathode, oxygen combines with electrons, right? Cathode side is oxygen side, anode side is hydrogen side. Then they combining together with electrons, and in some cases with specific such as the proton or water, resulting in water or hydrogen, water and hydrogen respectively. Then the electrons from the anode side of the cell cannot pass through the membranes of the positively charged cathode. They must travel around it via an electric circuit to reach the other side of the cell, because the traveling, the movement of this particular electron is happening, which is only happening through the electric circuit to reach at the other side of the cell. This movement of electrons is an electrical current, right? The amount of power produced by a fuel cell dependent upon several factors. The amount of power produced by a fuel cell, it is basically dependent upon the several factors such as fuel cell type, their sizes, the temperature at which it operates, and the pressure at which the gases are supplied to the cell. So if we ask about which parameter, about or list out the parameters in which the uh, particular fuel cell technology depends. The fuel cell depends upon the factors like the fuel cell type, which fuel cell of type you are using into this particular thing, right? The cell size, about the size of the cell, which size of cell you are using for this particular cell, the temperature at which it operates, and the pressure at which the gases are supplied. So there are plenty of other parameters also apart from the existing, apart from the technology, which is directly or indirectly affecting its performance, right? Still, a single fuel cell produces enough electricity for only the smallest applications. Thereof, individual fuel cells are typically combined in series into a fuel cell. A typical fuel cell stack may consist of hundreds of fuel cells. So this is from the fuel cell type. This is what we have discussed. If you look into the battery side also, like the how the battery, this is the fuel cell and batteries, and from the battery side also we have said, technically both the things, when we are discussing the fuel cells also, it is somewhere or another playing the same role, because it is also a story, because it is the combustion is not taking place, so we have like the secondary fuel we are using into this particular type, so we are able to produce the electricity directly. To state the various means, if you look into the battery side, the electrochemical device, which is also electrochemical device, again in that particular battery case, electrode phase, electrolyte phase, and charge transfer. The electrochemical devices have these particular things, especially when we are looking to the particularly for the battery side, like it is the electrochemical device. If you look into this particular side, we have this particular thing, from the battery side. If you will look, so we have this, we have particularly possible of this particular side, right? Electrochemical device. This is the electrode phase we have. For that we have the electrode phase. For that we have the electrolyte phase, and we have the charge phase, right? It is basically the cell is the energy storage devices, and again one side is the anode, one side is the cathode, one side is the electrolyte external circuit which provides the flow of the electron and indirectly the electrical circuit where we have the able to produce the electricity into the same case also. Anode oxidations, loss of electrons happens into the anode side, right? And cathode side is the reduction side, which is gain of electrons. So one side the loss of electron is taking place, and the another side is the gain of electron is takes place. And due to the loss and gain and the movement of basically of the electrons, we are able to produce we are able to produce the electricity. And so the side of anode is the gain, means the side of anode or oxidation stage is the loss of electron side. The side anode with the loss will occur into this particular side, and from the cathode side it is basically the reduction side, and the gain of electron will take place in that particular side, right? The energy storage device, fuel and oxidant are stored within the device, right? Because there is no external, we are not supplying. As we are supplying, we have to supply into the case of the fuel cell technology, we have to supply the hydrogen fuel cell from the external sources. But this is what not happening in the energy storage devices. The fuel and the oxidants are stored within the device, right? Energy conversion devices, fuel and oxidant are stored external to the devices. When we are when we are actually energy conversion, this is basically the energy storage device. So what we call, if we are talking about the battery storage systems, when we are talking about the battery storage systems, so then that particular battery storage systems, we can say that the what is the basic fundamental of the battery storage devices. These are basically the battery storage devices are basically what they are energy storage devices, right? And what is happening inside these particular devices, why we call them battery storage devices? Because fuel and oxidant are stored within the devices, means we haven't have any external source. We have both the fuel, we have both the fuel and the oxidant, which is basically one of from the anode side, one of the releasing of electrode, and one of the cathode side. We haven't have anything from the external sources. What we have is basically from the inside this particular thing. And once we have it, once we have this particular energy storage devices, what happens in that particular case? We said, okay, look, the fuel and the oxidant are stored within the devices. So this particular thing, which is like the energy storage, is occurring device which in which the fuels and the oxidant are, because both of them dealing with the same thing. Both have this pure anode and cathode and the catalyst in between, and which is the sandwich of this all this. So both they have technically both they have the same things, but the basic difference in the case of energy storage devices, when we considering any device is the energy storage device, both of these things stored inside the devices. But if you look into the another side of it, once we have the another side of it, once we said that then the what is the devices, once we have the fuel and oxygen stored external devices, right? If the fuel and the oxidant are stored in the external devices, if both the things, and we said in the case of energy storage devices, although they are looking similar, so what is the basic difference? How we can differentiate then? In one which we said, okay, fuel and oxidant are stored into the within the device, and the second side we can say it, because if fuel and the oxidant are stored external to the devices. Because look into the case of fuel cell, we look into the case of fuel cell, what is happening there? Because we have to have the fuel cell and the oxygen from the outside, and this is we are having as a consumable. So that particular device, rather than energy storage device, we call it energy conversion device, right? We call it energy conversion device, right? We call it energy conversion device. So this is basically the basic difference between the both of these technology. One side we have the storage, and the another side we have the conversion devices. Classifications we can have the based on the type of electrolytes we are using, based on the types of fuel cell we are using. If based on the types of fuel cell we are using, we can have the hydrogen pure, oxygen pure fuel cell, pure hydrogen, pure oxygen fuel cell, we can call it. Hydrogen rich gas, air fuel cell, we can call this. Ammonia air fuel cell, we can call this. Synthesis gas air cell fuel, we can call it. Hydrocarbon gas and air fuel cell, it is the one of the classifications on the basis of the
type of fuel cell we are using based on the operations temperature, based on the type of electrolytes we call it alkyl fuel cell. It call it AFC. We call it phosphoric acid fuel cell. PAFC, phosphoric acid fuel cell. Polymer electrolyte membrane fuel cell. PEMFC. So whenever this FC words coming into done, basically this is dealing with the fuel cell technology, and it is basically the polymer electrolyte members. When we have the MCFC, is the molten carbonate fuel cell. When we said SOFC, it means we are talking about solid oxide fuel cell. So these are the different categories we have distributed. So each of them need to be basic fundamental basic principle of each of these technology is the same, but they are different with the with their with respect to their the way they are dealing with it, whether it's alkaline fuel cell and anything else. So this is basically the all about this particular fuel cell technology and the batteries and the basic differences between both of them. If you have any questions regarding this particular lecture, you can ask.